Hello everybody and welcome back to CSCI 210. In this video we will demonstrate the three types of iteration control structures. The first one will be the repeat number of times iteration. I have Lightning here to help me demonstrate these. Well, first thing we need to do is connect to our robot so we don't have the broken-hearted panda here. Okay, we're connected and we're going to move to upload because that's what we do. So, first thing we always start with is we start with a start event. The start event is when you start up the robot. Okay, the next thing I will do is I will do a control and we will demonstrate the repeat number of times iteration control. Now, we don't want to repeat what we're going to do 10 times, let's just do 5 times. Okay, and pop on here, we're going to make noise because it's fun to make noise. And we'll flash the lights because it's fun for the lights to flash too. Okay, now what happens is Lightning can do things a good deal more quickly than we can catch up with, so we will not see this change. It will happen so rapidly. So what we will need to do is we will need to put a little delay in there so that we can see it. And we do that this way. And we'll say half a second. That should be enough. Okay, and at the end of it, we want to put everything back, so and the way you set it off is you put everything this way. This will turn the lights off. Okay, let's upload this to Lightning and see what happens. Like I said, let's upload, not switch modes. Oh no, it didn't happen. Okay, looking at it, I see what didn't happen. I got Lightning turned off. Let's turn Lightning on. Okay, and he's got a result of the previous program, so okay, we got his attention. He's learning. Okay, and it looked like it worked. Okay, let me shut him off. Turn him back on again. Okay, now you notice that this program starts just as soon as it runs, and there's nothing we can do to delay it or anything. We'll get back to that later. Okay, so that was a repeat number of times iteration. Okay, we'll tell you what, to save time, we'll go to a different type of one. Let's go to repeat until. And what I'm going to do is I'm going to salvage all my code from this. That's nice. Did it for me. Nope. Okay. Okay, what do I want to repeat until? Well, you know, I'd like to have some control over this. Let's see if we have some sort of event that I can control. Nope, that doesn't work. How about sensing? IR remote. Hey, this one looks good. Okay, A and B are kind of used already, so just to keep things straight, I'll say let's repeat until IR remote, and I kind of know where I'm going to go with this eventually, so I'm going to pick D. Okay, so what will happen is it will continue to cycle this until the IR remote D is pressed. D right here. Okay, so let's upload this to Lightning, see what he thinks about it. Okay, he's starting to go over and over and over again. Press D, and it stops him. That's kind of nice. So what happened is this will continue, instead of continuing to go and continue to go for a certain amount of times, it continues to go until I stop D. That could be 1 time, that could be 5 times, that could be 10 times. So this is an example of repeat until iteration. Okay, put these out here to the side, this in. Okay. We also have the do forever. Remember that you don't want to use do forever unless you mean it. Now what happens with Lightning is we want him to sit there and we want him to execute a program once he starts up. And later we'll actually have him listen for events. So when you have something like Lightning, who is going to be working autonomously, we want this do forever loop because we want him in the program once he starts the program till we tell him otherwise. Now, what is wrong with doing this? Notice it doesn't even let you do that, because if this is a do forever, you will never get to this. But what happens if we download this the way it is? Okay, he just keeps on doing this forever and ever and ever and ever. We will probably need to have what happens with program is sometimes you accidentally create a forever loop because you create no exit condition or your exit condition never happens. Now, there are some rare cases where a forever loop is appropriate, such as with an MBOT, so that we can have an event loop to listen for him to happen. Now, another example of an event loop is when you're using the computer and you're using word processor or you use an Excel or something. The computer will just sit there and wait for you to push a key, and it'll basically wait as long as it's turned on. That's another example of a forever loop. Okay, so we have covered the repeat number of times iteration, we've covered the repeat until iteration, and we've covered the forever iteration. And I'll shut him off. Okay, if we want to start writing programs where Lightning moves, we really need to be able to stop and start the program, especially if the program goes south like it already has a couple of times. To do that, we will need to add an if statement. Next week, we'll learn how to nest iteration structures such as repeat until and decision structures such as if then else. See you next week.